Okay, so today we're going to continue our discussion of special centers of a triangle. So today I want you to sketch or draw the angle bisectors of triangle ABC. So if I draw the angle bisectors, remember an angle bisector bisects the angle into two congruent halves. I'm just approximating. The best way to do this would be to do a construction. However, we're saving all our constructions until later in the year because of the virtual learning. So if I approximate my angle bisectors, I'm doing them in 3 different colors. You will notice that the angle bisectors all meet in a single point in the middle of the triangle. And that is because the angle bisectors of any triangle are concurrent. And this point of concurrency is called the incenter. And just like yesterday, we learned the circumcenter, and we have to memorize that that's where the perpendicular bisectors meet. We need to memorize that the incenter is where the angle bisectors meet. And just like the circumcenter is equidistant from all the vertices, our incenter is perpendicular from all the sides of our triangles. Now remember, we always measure distance at a right angle. So I'm trying my best to approximate this. And it may not necessarily, oops, didn't mean to erase that line. It may not necessarily always be on the angle bisector. Actually, most of the time it's not how I measure the distance, but they are indeed always equidistant from the sides because our theorem says the bisectors of the angles of a triangle are concurrent at a point equidistant from the sides. And this point is called the incenter because it's the center of the inscribed circle. So find each measure if S is the incenter. So we need to remember that the incenter is where the angle bisectors intersect. So that means that each angle here is equal to the other side, 31, 31, 28, 28. And then to find this angle, we're going to use the triangle. So we have 62 plus 56 plus x equals 180 because we need to remember the angles of a triangle always add up to be 180. So this large angle is 62, meaning that each part is 31. So the measure of SPU is 31 degrees. Now SU is equidistant to SR is equidistant to ST because the distance from the incenter to all the vertices are equal. Now the question is, how can I find SU? Well, to find SU, I need to know that this is a right triangle, and I know that this is 8 and this is 10. Therefore, I can use the Pythagorean theorem to find SU, which I'm going to call y. So the Pythagorean theorem is a squared plus b squared equals c squared, where A and B are the legs. So it's y squared plus 8 squared equals 10 squared. So that's y squared plus 64 equals 100. Subtract 64, and I get y squared equals 36. So y equals 6. So SU is 6. Angle bisector is a segment from the vertex to the opposite side that splits the vertex in two congruent triangles. Median of a triangle two congruent angles. I'm sorry, I misread that. It's angles, two congruent angles. The median of a triangle is a segment whose endpoints are on a vertex and at the midpoint of the opposite side. So we're just going to draw again because we haven't learned how to construct and it's hard to construct. So the median from A starts on A and goes to the midpoint of the opposite side. The altitude of a triangle is perpendicular segment from the vertex to the line containing the opposite side, and that's always perpendicular. And again, we're just going to draw this. So this looks to be an obtuse angle, so our altitude from C to A is going to be on the outside of our triangle. Altitudes are not, two of the altitudes in an obtuse triangle are outside. The one going to the longest side is on the inside, and these will intersect at a point of congruency. So in each triangle below, name the type of segment that CD is. So CD is an altitude in A, and B is a median because it's bisecting AB, and C is the angle bisector, and in D it's the altitude. Polygon ABC is a triangle, CD is an altitude, CE is an angle bisector, and CF is median. So I want you to pause and answer A through D. So letter A, we're looking for two congruent angles with a vertex at C. Well, we know CE is the angle bisector. Therefore, those angles would be ACE and angle BCE. Two line segments that are congruent. So we know that CF is the median, and the median bisects the side opposite. Therefore, I know AF is congruent to BF. Two line segments that are perpendicular to each other. Well, we know CD is the altitude, therefore CD has to be perpendicular to AB. Name two angles that are right. Well, since CD is perpendicular to AB, we know that angle ADC and angle BDC are right angles. So that's it for today. We will work on the classwork tomorrow. If you have any questions, please bring them to class.